are some resources. So at the top here, actually I should start at the bottom. So all of these resources are available on the Gravitational Wave Open Science Center. The website's right here. It's gwopenscience.org. Very easy to find. So the first one at the top is called the Learning Path. There's 2 tracks. Most of you in the room can probably skip to the second tab, which is for researchers. That's you. And that'll have a number of suggested things that you can look at and learn how to work with gravitational wave data. We're going to look at least one of these. So these are signal processing tutorials. So these are intended to be very gentle and introductory. We'll look at those today. That's more or less where we'll start. There's an entire online course. I'm going to encourage everyone, we'll have about 30, 40 minutes to look at this. And I'm going to encourage when we get to that segment of it, I'm going to encourage everyone to register for that. So far, there's about 900 people who have registered. So if we all do it, we'll get to 1,000. That'd be great. And then that's coupled to these open data workshop tutorials. So these are all Python example code showing you how to work with LIGO data. And we're going to take a look at those as well. So we'll work through some of this today. So I have to say, what I'm going to share with you today is a grab bag of stuff. 5 points about it. This is a live interactive session. Some of the things you try will probably be too easy. Some of the things you try might be too hard. Some of the things you try are not going to work, right? So live sessions, live demos, things don't always work. I apologize in advance, but it's a reality. Point number 4, it's almost certainly too much. I'm almost certainly giving you more to do than you can do in the time allowed. But point number 5, the good news, if you're into it, if you like it, if you want to figure it out, all of this will be available online indefinitely. So you're free to continue it on your own. Okay, so these are all the things we're going to try out today. They're all available on the website. You can find them. You can finish them later or not, as you like. Everybody clear? Okay, great. We're being recorded. Great. Okay, so this is a rough schedule. We're going to start with this, with kind of an introduction to signal processing. Put your hand up if you've worked with some digital signal processing before. Great. Okay, so for those of you who have done some digital signal processing, this will look really familiar. For those of you who have not, this might look really new. So that's great. We're going to start with something that's intended to be pretty gentle. So there's this app. So I'm going to give you all about 7 minutes to explore the app. The link is in the Slack. So if you look in the Slack for this link, or you can get to it from the learning paths, but probably the easiest thing if you go to Slack and find this link. The first time you click it, there's a stability issue lately with it. I guess I need to debug it. So when you click the link, you may see a message that says over resource limit or ARG. Try reloading it. It worked once you reloaded it. Yeah. So there is an issue there. If maybe, I don't know how much resources are committed to it. So if all of us doing it crashes the app and it doesn't work, no problem, try it another time. But let's all try it, give it a couple reloads. And I'm going to give you just like maybe 5-6 minutes to explore it. This is the part that uses headphones. So if you have headphones, now's a good time. All of the links are in Slack. So, okay, so I'll call time on that. So that did not go so well. So my bad on that. So the app, what's that? Like that particular app? I'm not feeling good about that app, to be honest. Like something terrible has happened. I'll tell you what I can try. Let's see if I'll show you something else just for fun. Let's see. Let's see. I'll tell you what, I'll try my luck with another one. That app about a week ago crashed and I haven't had a chance to debug it. So I'm going to check the other one and I think it's working as far as I know. For what it's worth, like most LIGO data analysis is not done through online apps. So good news, you're not missing a lot. But let's see, let's try this for fun. New share, Safari, close out. So this one I actually kind of like. This is the Quick View app. And this guy, oh, let's see, it's got a sidebar. And so you can choose some data. So you can select by event, or you can, or you can select by GPS time. But I think it's a lot more fun to choose your favorite GW event. And so we'll start there. And then what this does is it grabs the data out of the archive, it plots it. So this is the raw time series data. Then applies some filters and you can see the filter time series. And here, this is 150914. So you can see the signal. And then down here is a time frequency plot. I realize I didn't cover, is everybody comfortable with this kind of plot? Can you just nod your head if you understand what you're looking at here? Okay, great. So that's all good news. So I kind of, at least in principle, I like these Streamlit apps because they make like kind of relatively user-friendly ways to get at our data. And then down here is like some controls. So you can adjust the plot, like parameters if you're into that. So, when they work, these Streamlit apps, I think they're cute. I think they're fun. They're not really necessarily research tools. They can be tools to make plots for like presentations and things. I'm working on one for plotting in posteriors, which I think will be useful for like talks and such. I switched to the binary neutron star. So let's see, this one at first you can't see the Q transform. You can't see the spectrogram, but oh, well, a couple tricks. So one, you got to get some data where it's present. So let's get the Hanford data for the binary neutron star. And we can make the time range just a little longer. And we'll turn the Q factor up to maybe like around 100. And then maybe we'll get a good plot of that. Let's see. Oh, what'd I do? It's broken. Where is it? Oh, the Q. Oh, I grabbed the wrong slider. Get the Q up to 100. Put this down to like 20. Yeah, so the Q value, that's a good question. So the Q value is the number of cycles at a given frequency value. So it's sort of a characteristic number of cycles. So a binary neutron star is in the LIGO band for a long time. So lots of cycles. Oh yeah, so there it is. So there's the binary neutron star data. You can see the chirping pattern there. Okay. So app number one didn't work so well. Let's move on. The next item we're going to try are the intro tutorials. These are going to work in my binder. So let's see, if you go to, so it's this GitHub repo. It's github.com, jcanner, GW intro. The link is in the Slack channel. And then from the GitHub repo, there's a My Binder launch button. I can show you that if you like. Let's see. If we go to screen share, Safari. And so here's the GitHub repo. And then if you scroll down, there's a launch binder button here. And that this should load reliably. I don't expect performance issues here. It takes like around 30 to 60 seconds to load. So you'll see a screen like this. And then if you show here, it should just say launching server. Usually takes about a minute, and then hopefully that'll launch up. And then it has something like 6 Jupyter notebooks, and you can use all of them. They should all be live and interactive. And so you can get started on that. So I'll give you, how are we doing on time? So let's see, 6:30. Yeah, so you can go through them. They do have check questions at the bottom. I don't think you'll have time to do all the check questions, but I certainly encourage you to take a look and just consider. The very first notebook 0 is just some kind of introduction to Python. If you've used Python before, you can skip notebook 0. Notebook 1 is a very gentle introduction to like digital signal processing, and then it kind of goes from there. And so I'll give you just about 20 minutes to explore those resources. Okay, let's pause there for a moment. So put your hands up if the My Binder tutorial is at least loaded for you to at least work, more or less. Okay, good. Show me if it was too easy. Aha, okay, good. Show me if it was too hard. Show me if it was about right. Oh, okay. Yeah, that's okay. Yeah, a lot of hands. That's okay. It can be too easy and too hard. That's okay. Great. That lets me know how I'm doing. So we're gonna pause that now. Obviously, if sometime later you're really interested, you want to spend more time on those, great. But for right now, I want to try and make a jump and try like another resource just to explore. So we'll try this open data workshop. So there's an online course that's here. I encourage you to register. It has like quiz questions and things like this. It'll walk you through, do this tutorial, do that tutorial. All the tutorials, you can load all the tutorials into a My Binder. I put that link into the Slack. So if you go to the Slack, you'll see this GWODW My Binder link. If you get that working, let's see. Oh, I see. I have to switch the share. New share. Fantastic. So here's a new share. So if you get that My Binder link working, you'll see a screen something like this, and you'll want to go to tutorials. Error. That's not good. That's a disaster. Anyway, hopefully it'll work for you, and you'll see. Oh no. All right. So who knows? So you'll try it. Hopefully it'll work. So you'll go there. Hopefully you'll find some tutorials. I want to focus. There's a bunch of stuff there that usually we run these open data workshops. We usually give people, we spread these tutorials over like 3 days. We have not 3 days, but we have like maybe 30 minutes. So I'm going to suggest, so it's way too much for right now, but I'm going to suggest just a few that I think are in some sense my favorites. So I'm going to suggest you try these 4. 1.2, 1.3. So the one is day 1. So you go into the tutorials folder, and then it's day 1. And you can try the day 1, number 2, 3, and 4. And then this one here is probably my favorite. This guy runs the match filtering code, so it shows how to search for a signal in a bunch of data. So that's kind of a highlight. And let's see, I think we've got just about 30 minutes to explore that. So I'm going to give us 30 minutes to try these 4 tutorials. Yes. Okay. It's possible. Let's see, what's it doing? Yeah, that's not great.
I tried it twice already.
Yeah, let's try it one more time, maybe. Yeah, it's not. No, no, no. I don't. Oh, yeah. Okay, if it's trying, let's see. Click the show button. Click show there. Yeah, let's see what it's doing. Yeah, that's what it should be doing. Oh no, launch attempt one failed.
The previous binder worked for me.
Yeah, that's funny. That's very sad. So the other option with these is these should be queued up to work well in Google Colab. And so that's an option as well. And so if you actually, with these, if you go to the GitHub repo,
I actually think I tried it before.
okay.
I'm just not sure if it's the same one. Can I just show you?
Yeah, that's it there. And did you install the software?
Yes.
Okay.
I had to make some bug fixes because actually there was never mind. But
Yeah, you can run it locally. That's fine.
so I can just do that.
Sure, it's great.
And then
Yeah, it's great. Yeah, that's fine.
and so then
Yeah, and try day one. Yeah, see what happens. Yeah, and try the number 2 there.
I
Yeah,
remember there was something.
there was some issue. Scroll up. Looks like it quit. Oh, that's funny. It's a weird error. Whoa, fixed a bug here.
Yes.
What? Oh, that's you.
There was an issue. There was an issue by it actually had another
Okay.
Yes.
Good. So that was my fault, and I fixed it on the server side.
Okay, so now
So if you undo, yeah. No, I'm sorry. Yeah.
All right.
No, 100% my fault. Well done. Yes, sir. Excellent. So around the Earth, there are satellites that we use for our GPS, right? They have very good clocks in them that are stable to, like, I don't know, 1 part in 10 to the 15 or something. So it's time measured. It's just counting seconds. So there's a certain start date, which is, I think, sometime in 1980. And the GPS time is the number of seconds since that start date, since GPS time 0.
Okay. So if I have downloaded data from GW OpenScience download data. So if I want to download the data, I need to specify the GPS time. So how do I give the GPS time properly?
I see. If you open up a new tab, so you can go to gw-osc.org. Yeah, that's it. And then yep, and then to that URL, add /GPS. Yeah. I can't see it, but I believe you.
/GPS.
Oh, we'll get rid of the about. It's just not about. See, it says about.
Sorry, I didn't.
See, it says about in the URL. Remove the word about. ABOUT. Yeah. All right, let's try again. Just go to the gwopenScience.org and maybe try. Yeah. No, the one that says grav. Okay, that's fine. Now go up to the menu. Go up to the menu. Look at online tools. Yeah, and you see GPS converter. Yeah. Is that the question you were asking me? Like, you can. Yeah.
Okay, this is how.
Okay.
Thank you.
You're welcome.
Long periods of time, no real signal. I'm having
Mm-hmm.
Like, I don't know why it's basically broke.
So it looks like you're running locally.
Yes, I installed all the things.
Okay. So
Like I was running
okay.
and I used the environment.
Yeah, maybe you close out the notebook and try launching it again, like from the terminal. As a guess.
I don't know if I had installation.
Could be. Did you use the Conda environment?
Yeah.
Conda's environment should be good. Those are pretty carefully.
All the others.
Yeah, they're pretty carefully. Oh no, there goes kernel error.
Yeah.
I mean, I'm really sorry. I don't know how to debug your computer. I mean, child. It says there's some. Let's see. Can you scroll to the end? Is it just /libraries or something at the end? Go all the way to the end. Let's see what file's missing. Python. It says Python's not there. That's not good. This says version 2.7. So hopefully you should be using Python 3. So wait, go back to the notebook. Can you change your kernel? Is my question?
Yes.
Change your kernel? No, change the kernel. Go under kernel. Change kernel. So you want to pick the Igwin, yeah. Maybe the Conda.
It's not showing here.
Okay, that's probably the issue.
But I started it in the comment.
Are you sure? Let's see.
Here it is.
Mm-hmm. Yeah.
I was also in this terminal.
Yeah. Yeah, so it looks good.
That looks fine. Python.
Yeah, that looks good. Okay, that sounds good. But then when you start the notebook, it's coming up Python 2. So something's funky.
I follow the instructions, so it says that it's Python 3.8. Like when I
Yeah.
when I do which Python version.
Yeah. So that's I don't know what's going on, but there's some environment issue where it's getting the wrong Python somehow.
Okay, sorry.
Yeah. No. It's a fair question. Yeah.
So I know about 2 years ago, a time where ICDC was still dependent on Python 2.7.
No, they've gotten past that. Yeah. No, that's okay. That was an issue for a long time, but they're past that. Yeah.
I just have a question with the window. What is this hand?
Oh yeah, so there's different shape windows. So there's, as you probably know, there's a little bit of art to signal processing. And so, yeah, so anytime you're doing some signal processing, so making a window or a filter, there's a little bit of trade-off because you're sort of corrupting the data in some way, right? Like a window is pinching the ends of the data. And so you might want, for different applications, you might want a window that has a certain frequency response or a certain shape, right? Equivalently. So what that refers to is a particular shape of window. It's a hand window. And that's just a particular shape of window that has particular advantages.
And how can you find those?
It's like,
shapes of windows?
I mean,
Is it like a set list? Or
there, well, yeah. So there are popular window shapes. And so it's the kind of thing you can Google and you can read about it ad nauseum. To be honest, I've never gotten interested enough to get it really well. But, there's sort of lore about, well, a hand window is good for this or has these properties, and a Blackman window. Like I know that a Blackman window is really good for reducing spectral leakage if I want to make a PSD. But the details of that are not something I've ever, spent time trying to understand. But in general, there's probably, I would say that day to day, I probably use like 2 or 3 windows at most, and sort of use whichever one works best for the given application. So it's a little bit of trial and error. I'm sure that there's better answers, but that's
I
That's-
think it'll just have to be something.
yeah,
And then I have maybe a dumb question.
I doubt it.
So in this first,
Yeah.
how do you know what to put for the sample rate?
Oh, it's a choice. It's a choice. So in this case, we're generating data from scratch. So I chose 2000 hertz kind of arbitrarily here, I think.
Okay, but I messed with it a bit and I turned 200 and just put it rate and I put like 20,000. What's the exact thing? So it's just
Well, remember, you always have to have a sample, you always have to have a Nyquist frequency that's higher than whatever information you're trying to keep track of. So in this case, notice there's a signal at like, yeah, so the, so that means that the Nyquist frequency had better be like 350 or more, or you're going to corrupt that data. So if you want a Nyquist frequency of 350, the lowest sample rate you can use is 700 hertz. Does that make sense?
Yes. We know.
Yeah, the sampling rate is double the Nyquist frequency. Yeah.
As long as you're
Okay, let's pause there for a moment to check in. I loved all the questions. Let me ask now, are there any questions folks are dying to ask right now? No? Okay, good. Yeah. Yeah, it's a great question. So the answer is that for our searches, we reduce to a 3-dimensional parameter space of mass 1, mass 2, and chi effective. And so in 3 dimensions, you can actually do it. And it's still a lot of computing, but it's a finite amount of computing and it can be done. And then after identifying the signals, then there's a second stage that goes back later and tries to fit with all 15 parameters, but that's done just for seconds of data where we know there's a signal as opposed to searching months of data. Yeah, correct. Good. Other questions? Okay, great. Excellent. That's great to hear. Thank you. Yeah, so these tutorials, the Open Data Workshop tutorials, I shouldn't take credit. So these are put together by teams of mentors across the collaboration. So we have these workshops and we invite in mentors and they work together on the tutorials. And I think that's a good model. So thank you for saying so. I'm glad you've had a good experience. Put your hand up if that was too easy. Aha, no, 2? Yeah, 3? Okay, good. Put your hand up if that was too hard. Okay, good. So I do want to take now, we have just about 20 minutes left. And so I want to encourage everybody to try the data challenge. Let's see if I can. So in the GitHub repo, nope, I don't have a link to it. Let's get a link up. So we're going to go to a GitHub repo that's github.com/GWODW/ODW 2021. I'll put that link in the Slack. Oh, that's why I heard an echo. What's that? It's already there? Okay, no problem. So let's put that in the Slack and then I'll go to, so here it is. Yes, you can see it. So github.com GWODW and it's ODW 2021. And then there's a folder for challenge, which is here. Good. And then in the challenge, there's a README. And the README is the challenge. There's no other file here. So don't be fooled. This is the thing. So it's basically instructions. There's links to the data files, but if you scroll to the bottom, it gives you a hint here, right? So this is to get you started. It shows you how to just, if you're in the My Binder, you can skip the installs and you can just download the data files. And then this shows you how to read them in. And then what we'll try to do are the first like 1 or 2 or 3 challenges. I think the first one is just read in the data file and plot it. So hopefully you can do that after your 20-minute lesson. And then if you're feeling brave, you can go on to say challenge 2 or challenge 3, where you actually run the match filter and try to calculate an SNR. Maybe some of you will, and of course for 2 and 3, you're more or less cut and pasting code from tutorial 2.2. So there's a hint. So I'll give you just about, let's say 15 minutes to try that out and just see how far you get. And ideally, you'd run this in the, if you've got like My Binder working or some environment where you've got all the software installed, you can run it in that same My Binder environment. You can start a new notebook in the same environment. I'm sorry?
It's not the tutorial.
Oh, yeah, I can put the challenge link into Slack. How about that? Would that help? So for folks on Zoom, the question was, what's the right link? So I'll add the challenge link to Zoom. Great. Okay, let's go ahead and bring it back together. So we are just about out of time, so I am going to wrap up the session. Did anyone have any luck with the challenge? Was anyone able to complete challenge 1? One person? Okay. All right. So, I mean, that was very limited time, right? So, yeah, so maybe 10, 20 minutes isn't enough, right? So again, usually we spend so usually for these tutorials, we do them over 3 days. We do between 6 and 9 hours. So obviously going from 9 hours to, 1 hour is a pretty big jump. So if you're interested, I do think the materials are standalone. So for example, if you want to spend more time on this on your own, so if you were to enroll in the online course, it's free. It has video recordings of lectures that are associated with this. So there's hours of lectures on videos, which you may or may not want to watch. And then there's quiz questions to walk you through each tutorial. So you do the check questions. And in general, if you spend a little more time on the tutorials and the check questions, then by the time you get to the data challenge, it should be hopefully no problem. And then again, there's, we try to emphasize educational materials. So particularly for graduate students, I think we have good things. So yeah, so I encourage you to look at it. You can also look at catalogs of events and see all sorts of papers and documentation and data files. So I think there's resources there. So hopefully this will give you a chance to get started and the opportunity. And I think with that, we should probably close the session and go get some dinner. Thank you all so much.
Thank you.